Okay, today we're going to take notes on 9.4 proportional parts and triangles. The first thing we're going to start with is a theorem. So if there's a line parallel to one side of the triangle and intersects the other two sides, then the triangle formed is similar to the original triangle. So there's a smaller triangle inside that is formed that is similar to the larger triangle that you started with. So here's the example. So it's given in the picture that that middle line that cuts through and intersects, it's parallel to the bottom base of the triangle. So we can write this as, if BC is parallel to DE, which it is, it's a given that it is right here with those arrows, then you can say that the smaller triangle ABC, which is this one, that little one right there that's created, is similar to triangle ADE, which is this bigger original triangle. Okay, and remember, order matters here. Okay, so we'll start with an example. We'll do a lot of examples today. So example 1 is complete the proportion SV over SR equals something over RT, and then the other proportion ST over SW equals SR over what? Okay, so in this case, you're not going to need to write statement reasoning columns, but you do need to write a sentence to explain how we can set these proportions up. So basically what we just learned, we're going to say, it's right here, it's given that these two lines are parallel to each other. So we're going to write, since VW is parallel to RT, okay, because it's given, that means that triangle SVW, so the smaller triangle that's created right here, is similar to the bigger triangle that was already there, SRT. SRT. Take a second to understand what that means. So now, you have to write that sentence to start. So now that we know the two triangles are similar, we can say therefore, and we're going to use this proportion up here that they gave us, SV over SR, so that's SV, and then SR is proportional to something over RT. Okay, well, RT is this over here, so it matches with this one in here. Okay, remember, RT, order matters. If we're talking about RT on this triangle, we're talking about VW on this triangle, so we have to write it in that order, VW. That's our answer to that. And the second proportion, ST over SW equals SR over what? Okay, ST, that's this side. Let's use a different color. Sorry, I'm marking it up a lot. ST over SW, yep, the smaller one of that same side, equals SR, the bigger one, over the smaller one up here, SV. Okay, order matters. All right, example number 2. In the figure, JK is parallel to GH. So I'm going to mark that up. JK is parallel to GH because that's given. So we need to find the value of X, which is this whole side FG. Okay, so we're going to write, we need to write down what we know before we can solve this, just like in the one above. So we're going to write, since JK is parallel to GH, which is given, that means that triangle, we got to figure out which two triangles are similar to each other. Let's start with the smaller triangle. FKJ is similar to the bigger triangle FHG. Okay, now we need to set up a proportion that works. So therefore, remember order matters, and you have to always put the same triangle on top. So let's start with the smaller triangle on top. So if we're trying to get to this x value here, FG, let's put that on the bottom, FG, then we need to put its corresponding side from the smaller triangle on top. So FG is the same as FJ. Is similar to FJ. So I'm going to put FJ up here, which is equal to, and then we've got to pick another set of sides where the numbers are given so it can finish out our proportion for us. So that's going to be the other side. FK on the top and FH on the bottom. And we picked that side because those numbers are given. Okay, so FJ is 8. And FG is X, which we're trying to solve for. Okay, and then FK is 6. And FH is actually that whole thing 6 plus 3, so that's 9 on the bottom. So make sure you do that correctly. And then we can cross multiply. Remember, you don't need to do a statement reason chart here as long as you start with that sentence that we started with. So this is going to be 6x equals 9 times 8, which is 6x equals 72. And so that's going to be divided by 6, so x equals 12. Okay, and that's it. Since it doesn't give inches or anything, we don't need to write inches or anything. Okay, example 3. In the figure, same sort of thing. Mn is parallel to KL, so I'm going to draw that in here. So find the value of x. All right, in this case, we're going to write since Mn is parallel to KL, which is given, we can say that triangle, let's look at the smaller triangle, JNM is similar to JLK. And now we need to set up a proportion with x, which is related to 12, and this smaller triangle side related to this whole side over here, which is 9. Okay, so I'm going to set up that proportion. Mn, you got to use it without the numbers first. Put the segments in there. Mn over its corresponding side KL is proportional to Jn over its corresponding side JL. Okay, and then you just plug in what you know. X over 12 equals 6 over 9. And now we can cross multiply. So that's 9x equals 6 times 12. 9x equals 72. Divide by 9. X equals 8. Since there's no units like inches or feet, we can leave it like that. And since it's asking us to solve for x, we're done here. Okay, example 4 is very similar. Let's just keep going. AB is parallel to PR. And then you guys should probably pause the video and try this one on your own and then check your work with me. Okay, we got to find the value of x again, which is this whole side R to Q. So I'm going to write since AB is parallel to PR, which is given. I'm going to put lines above those. Then triangle, let's look at the smaller triangle, QBA is similar to QRP. Remember, order matters. Okay, so we can go ahead and make a proportion here. It needs to include x, and it needs to include these two sides because we have those numbers. Okay, so I'm going to do QR, which is x, over the smaller side that matches it, which is QB, equals, and since we did the bigger triangle on top, since the QR comes from the bigger triangle, we need to put the bigger triangle's other line on the top here as well. So that's going to be PR, and then the smaller triangle on the bottom, AB. Okay, so QR is X, QB is 5, PR is 8, and AB is 4. We can cross multiply. We get 4x equals 8 times 5. 4x equals 40. X equals 10. And we're done there. You can show your work exactly the same way when you have to do this on your own, okay? Theorem 9.5. So another theorem. If a line is parallel to one side of a triangle and intersects the other two sides, okay, so just like the last one, then it separates the sides into segments of proportional length. Okay, that's interesting. So this has nothing to do with the triangles created, so this is a whole nother theorem. So the example here would be if BC is parallel to DE, then AB over BD, so let's see what that is. That's this side, and AB and BD, so the two segments that it is split into, is proportional to the other side, AC over CE, so this side over here. So that's what we just did. We just split that those sides into smaller segments, and then those segments are proportional to each other. Okay, so let's do a couple examples with this. So in the figure, RS is parallel to UV. So I'm going to write that in here. And we need to find the value of X. Okay, this is one of those cases we don't have enough information to figure out the two triangles being similar to each other, so we're going to use that second theorem about the side lengths just being proportional to each other. Okay, so in this one I'm going to write, since, I do need to start with a sentence, since RS is parallel to UW, which is given, we can write that RV, so we're going to split this side into two, so RV over RU equals, and then we're going to do the same down here, SV, we're going to split it into two right here, and over SW. Okay, so we can just plug in what we know. 4 over X equals 5 over X plus 2. Remember, order matters here, okay? So since we did this small segment down here on top, we also need to do that same segment down from the other side on the top of the fraction as well. Okay, so we can start solving this. We get 5x equals 4 times x plus 2. We have to multiply that out. Oh, I didn't save myself enough room. That's okay. So I'm going to write it right here. 5x equals 4x plus 8. I'm going to subtract this 4x. And I get 8, and I get x on this side. So it's solved for me. X equals 8. And since we're just solving for x, that's the end. Okay, and then the last problem, in the figure, GH is parallel to BC. So I'm just going to write that in here. Find the value of X, so very similar setup. Since you can go ahead and try and pause it and do this one on your own if you'd like to. Since GH is parallel to BC, then we can set up the proportion. Let's split this side into two parts first. So AG over GB, and let's do the same over here, AH over HC. Okay, plug in what we know, 3 over x equals 4 over x plus 5, and then we can cross multiply. We get 4x equals 3, and then you multiply times all of x plus 5, which means we need to distribute. Subtract that 3x, and we get x equals 15.